This afternoon, the first topic I will show you is the compound semiconductors, the next generation of semiconductors, presented by the original presenter is Mr. Americo Lemos, Chief Executive Officer of IQE, but I'm sorry he is not present in person here. So the speaker I want to introduce Mr. Simon Dann, President of IQE Taiwan, and welcome Mr. Dann.
Good afternoon, everyone. It's my pleasure to present IQE Taiwan to the Power Semiconductor Forum. Today's topic, we want to, the introduce of compound semiconductor, the next generation of semiconductors. Compound semiconductors are everywhere in our life. At this moment, the power conversion, power received from the solar cell, and the sense for the electric car, and the sensing of everything by compound semiconductor, and also the connecting people's connecting device through the wireless communication, also empowered by compound semiconductor, and also the display of our portable device and display. Compound semiconductor is basics to supporting the requirement that silicon not able to support due to the material characteristics, like operating at higher frequency and operating at higher voltage bias and also higher temperature. And most important is the light emitting and the detection. Okay, so the future in the demanding of our human life requirements, that is a lot of compound semiconductor supporting to get enrich our life. And the key megatrend for the current decade, like 5G connectivity and automation, the electric vehicles, and Industry 4.0, and the edge computing and healthcare. Many things are the megatrends of this decade. So we pick several megatrends to show you that creating the demand for electronics, like intelligent connected device that everyone wearable, and also for the Industry 4.0, there's many sensing of the device. And second is intelligent transportations. You need the sensing, you need the data transmission, many things. Also supporting compound semiconductor, creating the demand for the electronics. And AI on the edge and the metaverse. Those things create a lot of demand of the electronics. What materials to support the electronics that we need? At the left side, we have gallium arsenide, indium phosphide, and the gallium antimony. Those are light emitting or receiving for the image, and also the operation of the high frequency. And the right-hand side is the silicon and the related material that's supporting the silicon-related integration. And the middle side is the gallium nitride on different substrate that supporting many demands for the compound semiconductor need. And today, I'm very very proud to come over here to present you, especially as a manager, general manager of IQE Taiwan. I would like to introduce what's the importance of the compound semiconductor going forward. We want to scaling the compound semiconductor to 200 millimeter or 300 millimeter to align with the global silicon standards. It's about time to get a lot of demand. So we need a lot of device. We need manufacturing like silicon standard, automation, and standardization. So we need the follow or learn from the silicon experience so we can get a manufacturable, mass productionable compound semiconductor. And also, I want to show you is the technology available for the large size, scaling large size epi wafer compound semiconductor materials now is available for our customers for the silicon over 200. So this is the first one of 200 millimeter VCSEL wafers that's gone by IQE to the world and cooperate with the Silicon Foundry. So this is about time to change. So from now on, basically, compound semiconductor is entered to the 200 millimeter world. Okay, now we pick several application megatrends enabled by gallium nitride. The compound semiconductor is too many materials. From now on, I'm using gallium nitride as the first example to presenting the compound material enabling the megatrends. First is the intelligent connecting device about the connector and also the power and the display. For gallium nitride and application, very usually we use the frequency as a horizontal scale, and vertical is a operating bias. For higher frequency, like satellite communication, several gigahertz, several tens gigahertz, or the cable TV to 1 gigahertz, and the lower frequency to like a cell phone. And the operating voltage, we can from normal DC-DC converting to the vehicle car to the inverters to the grid or train. That's very high voltages as a gallium nitride application field. And then another thing for the gallium nitride is light emitting. So gallium nitride, by manipulating gallium and the indium composition, we can manipulate the band gap from long wavelengths to low wavelengths and covering the RGB band gap. So basically, gallium nitride is capable to emitting different light through the manipulating of the band gap of the material. And for those gallium nitride application, substrate selection is quite important. Depends on your application need and also the environment. So the selection will be like a gallium nitride, then the substrate will be very suitable for the high operating voltage. But there's a pro and con. The con is the substrate large size is not very easy to available. So silicon carbide, and the sapphire, also the application substrate available for gallium nitride. But for different application, depends on the cost, depends on the availability. So you can select different kind of substrate for your application. For example, gallium nitride using the higher frequency, the selection of the substrate will be gallium nitride on silicon carbide, because the operation frequency is higher, the demand also the power output. So there's a selection in the gallium nitride on silicon carbide. And for the power conversion, you want the best power conversion that you gallium nitride on gallium nitride. So there's an overlap in the gigahertz range to 10 gigahertz range. That's a the overlap for the power and high frequency. That's the area most people using gallium nitride and silicon to this operation range. So the first one of the intelligent connected device, which is the market cap is about 1 billion. Then this is belong to IP range. We can have a base station application, which we use in gallium nitride and silicon carbide. That's quite mature at this moment. And the new application is gallium nitride and silicon for the handset in the future. We will demonstrate that part later. And the power conversion, power electronics, about 100 million, 150 million market cap in 2026. But the high CAGRs is more attractive to most investors. That the electric vehicles we're using gallium nitride and silicon for the high voltage operation, which are available at this moment, going to boom up in the future. And next one, for the metaverse, there's a gallium nitride available for the micro LED, gallium nitride and silicon. This will be introduced later. And so as presented in previous slide, all gallium nitride is not created equally. So depends on the application, you need to select different kind of substrate. The subject selection according to the environment you want to overcome or the performance you want. So there's a 8-inch for the IP application that's on silicon or on silicon carbide. And the power electronics can gallium nitride on gallium nitride is available for 4-inch. But gallium nitride on silicon can be higher to 8-inch, even 12-inch. And the display, micro LED, that depends on the display quality you want. So basically, we provide the service from gallium nitride to gallium nitride on silicon to 8-inch or 12-inch. This is an example of gallium nitride on silicon for the IP application. For the left-hand side, they show you the difference between 4-inch and the 6-inch. That's the first migration from 4-inch to 6-inch for silicon, gallium nitride on silicon carbide application. And the middle part is show you the conversion power of 7.7 watt per millimeter at 35 gigahertz and 12.5 watt per millimeter at 10 gigahertz. That's the gallium nitride on silicon carbide application. And the right-hand side is first demonstrated about 0.25 micron gallium nitride on silicon, 200 millimeter device, the characteristic, which is available in 2014. This is the gallium nitride for mobile device that show you the manipulating of the indium and the gallium and the aluminum composition. So we can manipulating the light emitting the band gap from the long wavelengths, like red color, to the short wavelengths, always to the blue color. And just fine-tuning the composition and the lattice, and also the buffer. So there's a data show you that we are available. We are capable to manipulating those composition to deliver different color. And this was working with our customers also in 2014. And this actual one is available for the gallium nitride for mobile device, which shows we have a capability to overgrow the N+ gallium nitride by MBE system to reduce the contact resistance 1/3. So the heat loss at the drain can be reduced a lot according to this overgrowth technology. IQE is the only one in the world that providing both MOCVD and MBE technology to service our customers. And also Taiwan is the only site that equipped it with two technology at one site. And there's a very common application of gallium nitride for power electronics. Compared with the silicon, everybody knows the advantage of the gallium nitride providing lower resistance at the same bias or the same resistance at the higher bias. So the device can be quite compatible, smaller than silicon device. And IQE gallium nitride on silicon power electronics application can provide very low leakage buffer. At the left-hand side, you can see by controlling the buffer thickness, there's a leakage can be decreased by increasing the buffer thickness. And by right-hand side, show you the three-terminal testing can show you the linearity of the gate to drain distance, can control the different leakage, show you the increase of the bias breakdown voltage. Okay, then gallium nitride on silicon. There's another technology provider, IQE, can producing the back barrier to reduce the leakage current at high temperature. So for device operate at a higher temperature, you need very high heat resistance and also the low leakage. So IQE have technology of the back barrier to help the customer to reduce the leakage, actually increase the breakdown voltage. And recently, IQE make an announcement, co-work with a company, Polotech in the UK, and this is a unique technology which can save a lot of effort on the micro display pick and place. The same pixel can, by applying different voltage bias, you can get a different color emitted by the micro LED. So that's a breakthrough of the technology and to the micro LED display. So now, currently we have a 200 millimeter technology available, and we're also moving toward the 300 millimeter. So today I want to introduce this gallium nitride, for example, using gallium nitride as an example to show you the importance of a compound semiconductor to the world. And this is a very large market we can see at this moment, and this will motivate a global investment come to this field very soon. Actually, we already see many investors. And the second is we already proved that we can manipulate the precisely atomics into very precise the position of the atomic layers. So can create and manipulate the lattice and also the band gap to fulfill the requirement of a different product, of a different device. So the technology is quite mature at this moment. And the third one is very important, and especially I, as a general manager of IQE Taiwan, I would introduce to the Taiwan semiconductor field. That's the need to align with the silicon industry for the mass production and the automation is about time, because technology is available and the silicon technology also available. So we need to change to scale up our demand and scale up our production manufacturing to meet the need for a large quantity of the electronic device for the megatrends. Today is my presentation, and thank you.
Thank you, Simon. And now we are opening for discussion. So, please.
Okay, I have 3 questions. First is that I know IQE has a new technology building gallium arsenide for VCSEL on top of germanium substrate on 8-inch germanium wafers. To me, it's a game changer in terms of the cost infrastructure. Can you elaborate on the status of that? And there are some certain rumors that next generation of Apple devices will be using long wavelengths VCSEL, and has this technology and others been applied to that? Okay, that's my second question. The third question is, what percent of revenue does IQE Taiwan contribute to the total revenue of IQE as a whole? As I know that in the days of Kobin, the Taiwanese branch, the former name of Taiwanese branch, actually made quite a bit of revenue already before the merge with IQE. And what's the status in terms of the percentage of revenue now? Okay.
Okay, I answer the second question first. The revenue part probably confidential, but the IQE Taiwan is a very important manufacturing site of the IQE group. And very important according to several things is, one is the manufacturing capability, yield, and efficiency. Taiwan site is the #1 in the world. So basically, the investor also will come to here. And also because the geopolitical concerns, now IQE is the first and the only one company that has global footprint to support the manufacturing to every customer in every continent. So this is IQE strategy of the system. And IQE Taiwan is certainly important, but I may not tell you what is the percentage, but I can answer your question. Is quite important and quite a significant part. Yeah. And the first question is 8 inches, right?
VCSEL on the germanium substrate.
Yes, correct.
Right. Is it ready for mass production?
Yes.
Okay.
If you have need, please.
Yeah. The second, well, then I know that you have a patent on eliminated DBR in the epitaxys.
Yeah.
And that will save a lot of cost in manufacturing the wafers.
Correct.
But you need to develop quasi photonic crystal structure to
quasi photonic crystal.
Right,
yes,
to replace the
we have a
DBR.
patent on it. Yeah.
Right. Is it in mass production? Because that kind of need your nano imprint division, which I understand is sold through MBO.
Mm-hmm. Yeah. I will encourage you become our customer working on that product. Yeah, definitely we'll support you to get the product to the market. Yes. Second is the percentage of the revenue. Yeah. Long wavelength VCSEL. Yeah. Now it's available, and honestly, that's in pilot production already. Yeah. So if you have a need, please let me know. I can service you. No problem.
Okay. Do you have any question? No? I have a question. And you mentioned about maybe the IQE is the only one company can use the MB and MOCVD. And you also mentioned you use the gallium nitride MB system to grow the, for example, the HEMTO or
M+.
Only the M+.
Also the epi wafer, but too expensive.
Okay.
Yeah.
Okay. So
I know you don't have a problem. Yeah, no problem.
Okay. Okay, I see.
Yeah.
Okay, so the last question. Okay, if no any question, let us thank you, Simon again. Thank you.
Thank you.